In today class we will discuss about digital electronics. So it is also part of semiconductor electronics. In the previous classes we have completed first part of the chapter. So first part of the chapter means about semiconductors. What are semiconductors? What are the types of semiconductors? And also what is a PN junction diode? How it acts as forward bias, reverse bias, and also how a diode can act as a rectifier, half wave rectifier, full wave rectifier, and also optoelectronic devices means LED, light emitting diode, PD, photodiode, and also one more solar cell. Up to this concept we have discussed, and few problems also we solved. But next part of this chapter, digital electronics. Digital electronics. Digital electronics. So generally this part for PU level only 2 marks questions will be asked. 1 mark or 2 marks only. There will be no derivations and also no 5 marks or 3 marks questions. Only they may ask 1 mark or 2 marks questions for PU level. Digital electronics. Generally electronics means what? One of the branch of engineering, but actually it is also part of physics. So electronics means any generally branch of physics or branch of engineering which deals about electronic devices. So electronic devices means like computers and also mobiles or music systems, laptops. So all these electronic devices can be dealt by electronics branch. But in that electronics branch, one of the part is called digital electronics. So digital means what? In the circuits, generally we are having 2 type of circuits. One is analog and one more digital. Analog means, for example, if you take normal watches which are having a seconds hand, minutes hand and hours hand, so they will continuously rotating. For example, if a seconds hand completed 1 rotation, what is the time? 1 minute, 60 seconds. If a minutes hand completed 1 rotation, then 60 minutes, 1 hour. If hours hand completed 1 rotation, then 12 hours. Correct? Hours hand means having only 12 hours. Correct? So all these are having a analog. Analog means, for example, suddenly if a person asked what is the time, exact. If you are using analog watch, not numbers, not digital watch. Analog watch means we can say, generally we can say roughly 12:15. Correct? 12:15, 20 seconds or 30 seconds, roughly we can say. That is called analog signal, but the signal continuously changing. Correct? Continuously changing. For example, if you are using a bike, a scooty or a bike or a car having a speedometers. When we are moving on the scooty or bike, suddenly if you want to see the speed of the bike, so generally it is a 75 km/h or 60 km/h. Exact value we cannot say generally. So because it's a continuously changes. That's why roughly we can say the value. That is called analog signal. In the olden days, we are using TVs, like TVs, analog circuits, analog TVs, like having a dome type and a normal dish box will be there, or antenna will be there. That they are called nothing but analog. Analog means clarity will be less, quality also less. But nowadays we are using almost all digital electronics. Digital means like for example digital watches which are showing numbers. For example, suddenly if you asked anybody time, what is the time means exact time we can say 12 o'clock, 15 minutes, 25 seconds, exact time. That is called a digital watch or digital speedometers of the bikes. For example, if they are having only numbers, instead of needle, numbers will be there. So we can say the exact speed of the bike. For example, 80.22 km/h or 90.12 km/h. Exact numbers we can say. Nowadays we are using digital set-top boxes in our houses for a TV, or almost all the TVs also, LED TVs, there are also digital circuits inside. So without any dots, so clear picture can be seen with more quality and also more clarity. And digital set-top boxes also having nothing but digital circuits inside. So digital circuit means having only discrete values. Sharp values are discrete values, no continuous values. So either high or low, there will be no middle values. Whereas in case of the analog circuit, the signal changes continuously. There will be no breaks, no gaps. So continuously the signal will change, like similar to ammeter, voltmeter, this normal watches and the normal speedometer of the bikes. All these are nothing but analog circuits or analog signals. A signal which has the values varying continuously is called analog signal. A circuit which uses analog signal called analog circuit. But generally, a signal which is having only two discrete values. Here, what are two discrete values? High or low. Only two possibilities, no other possibilities. For example, true or false. Middle nothing will be there. Open or close. High or low. Correct. Means yes or no. Right or wrong. 0 or 1. All these are having only two possibilities. There will be no other possibilities. So, a signal which is having only two discrete values is called digital signal, and the circuit which uses a digital signal can be called digital circuit. So the digital electronics means what? The branch of electronics which deals about or which studies about digital circuits is called digital electronics. We can write simple definition: a branch of electronics, branch of electronics, branch of electronics which deals about or which studies about, branch of electronics which studies about digital circuits, branch of electronics which studies about digital circuits is known as digital electronics. Digital electronics. There are two types of signals. There are two types of signals. First one, analog signal. Analog signal. Second one, digital signal. Analog signal, digital signal. But analog signal means what? You can write next points wise, right? Generally, a signal in which the voltage or current varies continuously is known as analog signal. A signal in which voltage or current varies or changes continuously means it contains all the possible values, correct, continuously, is known as analog signal. A sinusoidal wave is an analog signal. A sinusoidal wave is an analog signal. Sinusoidal wave is an analog signal. Check it. The word sinusoidal indicates what? Which obeys sine function, like harmonic functions, like a sine function. That means if you take here sine 0, 0, sine 90, 1, sine 180, 0, correct? Sine 270, minus 1, sine 360, 0. So the values continuously varies like this, like high and low, like this only the values continuously varies. So this type of signal can be called a continuous signal, and it is called analog signal. Example, voltmeters, voltmeter, comma ammeter, analog watches, or speedometer of a bike, speedometer. So this type of all generally having analog signals only, they are continuously changes. And generally the electronics branch which deals about analog signals can be called analog electronics. That is called analog electronics. But second type, digital signal. What is a digital signal? Means only having two discrete values. A signal in which a signal in which the voltage or current, a signal in which the voltage or current having discrete values, having a discrete values. The word discrete indicates not continuous, having a discrete values is called digital signal, is called a digital signal. So we can take either time here, either voltage or current can be taken on y-axis like this. So the signal will be like this. We can take the signal like this. How we can write the signal means observe carefully this one. So here it is nothing but 0, and here we can take it is 5 volt. It is 0 volt. It is a 5 volt. So always 0 volt indicates signal absent. There will be no presence of the signal. Here 5 volt indicates signal present. So for signal absent we can take a 0. For presence of the signal we can take a 1. Again for absence of the signal 0. Again for the presence 1. We should write like this. So always we can say 0 indicates nothing but here not necessary. So 1 indicates a signal present, high signal, and 0 indicates signal absent, low signal. Again high, again low. So that means only two possibilities, either signal present or absent. For example, in case of the switches, while put on the switch for a fan or light, whatever may take, so there are only two possibilities, either switch is on or off. Whenever switch on, the bulb will glow or fan will rotate, and whenever if you put off the switch, then only there will be no glowing of the light. But middle nothing is there. Between on and off nothing is there, only two discrete values. That is called a digital signal. Observe this difference here and here. It is having a continuous changing values, but here no continuous changing values. Here for example 0, 0.1, 0.2, 0.3, 0.4 and so on. Again decreases, again minus, again increases, continuously values changes. But here no continuous change of values, only two values, 0, 1, 0, again 1, again 0, again 1, 1, 1 or 0, 0, 0 like that, but only two possibilities. This type of signal is called a digital signal. Example, digital multimeters. Example, correct, digital multimeters. Digital multimeters. Here multimeters means in laboratories we are using for finding either current or resistance or potential difference. We are using multimeters. So they will give only numbers. So the voltage is 22 volt, 30 volt, or 2 volt, or 5 ampere. Only they'll give numbers without any continuous values. Or digital clocks or digital watches. Digital watch or calculators. In case of the calculator also, there will be only numbers, no continuous changing values, only discrete values. Or modern computers or modern music systems, almost they are having a digital circuits, or modern TVs, circuits inside the TV, or maybe inside a set-top box, all are having only a digital circuits. Here the branch of the electronics which deals about the digital circuits called, or digital signals called digital electronics. Starting I have given a definition. The branch of electronics which deals about the digital circuits is called digital electronics. So generally digital circuit always uses what type of signal? Digital signal. But analog circuits uses analog signal. We can write the next point also. A digital circuit uses digital signals. A digital circuit uses digital signals. Next point. Analog circuits uses analog signals. Analog circuits uses analog signals. So from this concept we came to know we have two type of signals. One is analog signal, one is a digital signal, and one is analog electronics and analog circuit, and the second one digital circuits. So olden days we are using almost all the circuits are analog, but nowadays digital circuits occupy the place of analog circuits. So next 5 years, 10 years, almost all the analog circuits will be disappeared, and almost, but majority will be occupied by only digital electronics, so or digital circuits. So in this chapter we have to discuss only about digital circuit and also digital electronics. But if you want to perform the digital operations or operations in the digital circuits, so there will be some of the logic gates are required. Logic gate means what generally? In case of the room there is a gate or door. If you open the door, then what will be happen? If you open the gate, the persons can enter inside the room, or the persons can go outside the room also. So it act like whenever we open, we can allow the persons. Whenever if you close, we can stop the persons to enter or to go outside. In the same way, in a digital circuits, if you want to allow the information or if you want to stop the information, so there must be one gate like structure required, one digital circuit required. So that can be called a logic gate. Why it is called logic gate? It will perform logical operations. Whenever required, it can stop. Whenever required, it can allow. Whenever required, it can put high or low. That's why it is called a logic gate. So we can write what is a logic gate means. Note down that one. Logic gate. A digital circuit which performs logical operations. Digital circuit which performs logical operations. In case of the while writing computer programs, generally we came to know this type of logic gates. For example, in a railway station, whenever if you want to display a particular information, a train number I want to display, so we have to write a program. While writing the program in the circuit, you have to use logical circuits or logic gates. So particular number, for example, 1 required, only 1 will be displayed, and remaining all the LEDs will be in a off condition. For example, 0 required, so only 0 bulbs will be glowing and remaining will be in off condition. So the type of logical operation can be performed by a digital circuit which is called a logic gate. So a digital circuit which performs logical operations is called a logic gate. A digital circuit which performs logical operations is called a logic gate. That's a logic gate. But one more, generally digital circuits always uses one algebra. But whatever in mathematics you are using algebra, so that algebra is not useful for computers or digital circuits. A separate algebra with different formulae and different operations are required. That was developed in Bell Laboratories by one scientist George Boole. So which is called Boolean algebra. So that's only called Boolean algebra. Boolean algebra. So a digital circuit uses Boolean algebra. In the name of the scientist only George Boole, we can give Boolean algebra. So rather than normal algebra, it has a special functions and also special symbols. So in normal decimal system, we are having a total 10 numbers are there, 0 to 9. But whereas in the Boolean algebra, there will be no 10 numbers. So only we have two numbers. One is 0 and other one 1. Only with the two numbers, the total algebra will be based. So anything, any information if you want to give, so we have to give all in the form of either 0 or 1. For example, in a computer, whenever we are typing on a keyboard, whatever the information, bundles of information we type, but computer cannot understand. Inside the circuit cannot understand. First what we have to do, whenever we are giving information, inside the circuit will convert into computer language, like zeros and ones, and then it will perform the operations. And again while giving the output, that will be converted and it will the output will be for reader friendly, will be given generally. So Boolean algebra is used by digital electronics, and Boolean algebra is depends upon binary system. Boolean algebra depends upon a binary system. The word binary, bi indicates what? 2. Binary system means having only two numbers. Generally digital electronics depends upon Boolean algebra, but Boolean algebra depends upon or uses binary system. A binary system contains only two digits. A binary system contains only two digits, 0 and 1. It contains only 0 and 1, only two numbers. Whereas a decimal system contain 10 numbers, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So with these 10 numbers, we can write any number. With these 10 digits, we can write any number. Same way, by using a 0 and 1, we can write any number in case of the Boolean algebra, correct? Or in binary system. For example, I want to convert a binary system to decimal system, or I want to convert a decimal system to binary system. So which method we have to follow? For example, or in case of the decimal system, 10 numbers are there. I'll take one number, convert. For example, I'll give convert. Take any one number your choice. For example, I'll take 24. Convert 24 into binary system. So actually 24 is in a decimal system. The number 24 is in decimal system, but I want to convert this number into binary system. How to convert? What is the method? Means first we have to take a 24 here. So divide this 24 with 2, because we want to convert into binary system. That's why you have to convert into binary system. Divide with 2 until you are getting the remainder either 0 or 1. Up to last we have to divide. So 2 12s are 24. So 2 12s are 24 means whatever remainder we are getting right here 0. Check correct or not? 2 12s are 24. Remainder 0. Again divide with 2. 2 6 are 12. It is a 0. Again 2 2s are 2 3s are 6. 0. Again 2 ones are 2. Still how much is the remainder? So 2 threes are 6. Remainder 0. 2 ones are 2. But remainder 1 is there. Check correct or not? And then write these numbers zeros and ones from bottom to top like this. Bottom to top means therefore 24 is in a decimal system, but that will be equal to 11,100,000. Check correct or not? So 11,100,000 means here 1, 1, 0, 0 and 0. So this 24 in a binary system is equal to 11,100,000 in a binary system. Same way we can choose another number, like for example 48, or here 24 already given, may take another number, your choice, like 36. So convert 36 into binary system. Second example, it is our first example. Any number, your choice, take any number. So here we take 36 divided with 2. So 2 18s are 36, remainder 0. 2 9s are 18, remainder 0. 2 4s are 8, remainder 1. 2 2s are, correct? 2 2s are, should write 2 2s are 4, remainder 0. 2 1s are 2, remainder 0. Now write from bottom to top, same way. So the number 36 in a decimal system will be equal to 100, 100. Correct now? 100, again 100 in a binary system. That is a process to convert decimal system to binary system. Any number, your choice. You may convert like this. Same way in reverse, how to convert binary system to decimal system. Reverse we have to follow. Correct. I'll take one number and I'll convert a binary system to decimal system. But here we are dividing with 2. While conversion of a binary to decimal, we have to multiply. Here we are dividing, but there you have to multiply. Convert 11,100,11 into decimal system. Decimal system. So here also one example, write 3. I want to convert this number into decimal system. So what we have to do means first you should take this number 11,00,11. What we have to do means you may come from right to left. Correct. I'll take right to left. Right to left means how to multiply means first take the last number, last digit 1. 1 into, we have to multiply 2 to the power of 0. With 2 we have to multiply. Correct. Each and every number you have to multiply with 2. First number 2 power 0. Second 2 power 1. 2 power 2. 2 power 3 and so on you have to multiply. Plus. Now check second digit again 1. 1 into 2 to the power of 1. Plus third digit 0. 0 into 2 to the power of 2. Plus again 0 into 2 to the power of 3. Plus 1 into 2 to the power of 4. Plus 1 into 2 to the power of 5. Now you have to simplify. Your choice, or first from left to right also right. But for writing we have to count 1, 2, 3, 4, 5, 6 digits are there. So 6 means 1 is 0 means 2 power 5 onwards you have to come. Your choice. Now simplify it. That is equal to 1 into something power 0 equal to 1. 2 power 0 equal to 1. 1 into 1 is equal to 1. First digit. Second one 2. Third one 0. Plus fourth one 0. Fifth one 2 power 6, 4 means 16. Correct? 2 power 3 8. 2 power 4 16. 2 power 5 32. Now add these numbers, all the digits. 32 plus 16, 48. Correct? 48 plus 2, 50 plus 1, 51. So this will be equal to 51 in a binary system. It is a process. Any number given, it is a method to convert from binary system to decimal system. So still another requirement you write. You only and try one more number. Convert. Example 4. Still big number requirements your choice. 1, 0, 1, 0, 1, 0. Convert 1, 0, 1, 0, 1, 0 into decimal system. Decimal system. So you should write here first 1, 0, 1, 0, 1, 0. It is in a binary system. So how to convert means first you have to multiply from right to left. I want to multiply first 0 digit. 0 into 2 to the power of 0. Correct? 0 into 2 to the power of 0. Plus second digit 1. 1 into 2 to the power of 1. This one. Now third digit plus 0 into 2 to the power of 2 plus 1 into 2 to the power of 3 plus 0 into 2 to the power of 4 plus again 1 into 2 to the power of 5. So correct? 5 only total. 1, 2, 3, 4, 5, 6 digits means you will get 5 only. Now simplify it. Here 2 power 0 equal to 1. But 0 into something is equal to 0. First digit 0 plus second one 2. Third digit 0. Fourth digit 8. Fifth digit 0. And sixth digit 32. 32 plus 8 40. 40 plus 2 is equal to 42. So correct? That is in decimal system. That is a decimal system. Any number given should write like this. So for example, in a binary system and decimal system, if you compare the first 10 numbers, first 10 digits, for example, in a decimal system 0, binary system also the value will be equal to 0 only, correct? And decimal system 1 will take, but in the case of the binary system also the value will be equal to 1 only, correct? I won't write here 2, but in case of the binary system 2 will be equal to how much? There will be no other numbers. Only should write all the possibilities only with 0 and 1. How to convert the 2 into means you should write like this. 2 ones are 2. That will be equal to 0. Therefore 1 and 0 you should write. Correct? It will be equal to 1 0. But while reading it is not 10. While reading what you should read? 1 0. 1 0 only. One is a sum, one is a carry. One is called sum, other is called carry. For example, 3 is there. So 3 means how to write? With the 2 only. 2 ones are 2. Next one is equal remainder 1, 1 1. So you should write this value will be equal to 1 1. Next 4. Then try it. 4 means what you should write? 2 2s are 2 2s are 4. Correct? 0. Next 2 1s are 2. That equal to 0. 1 0 0. Correct? Should write 1 0 0. Next 5. If a 5 given, for example, 2 2s are 4. 4 means this will be equal to 1. Correct? 2 2s are 4 means 1. Again 2 1s are 2, 0. 1 0 1. So 5 will be equal to 1 0 1. 6 given, then check what is 6 value. So 2 3s are 6, 0. 2 1s are 2, that equal to 1. 1 1 0. Correct? That will be equal to 1 1 0. If a 7 given, so 2 3s are 6, 1. 2 1s are 2, 1. Triple 1. Correct? 1 1 1 should write. For the number 7 should write 1 1 1. If 8 given, so 2 4s are 8, 0. 2 2s are 4, 0. 2 1s are, that is should write remainder is equal to 0. Check correct or not? So here 2 4s are 8, 0. 2 2s are 4, 0. 2 ones are 2, 0. So 1 triple 0 you should write. This one for 1, 2, 3, 4, 5, 6, 7. Correct? 7 completed. Now for 8, this one. 8, 1 triple 0. 9, write up to 9. No need of remaining numbers. 0 to 9 only should write. For 9, check what will get. For 9, 2 4s are 8, 1. 2 2s are 4, 0. 2 1s are 2, 0. So 1 double 0 1. So next continuation. If any number given, it is only process. It is in decimal system. Decimal system. But this will be the same number will be in a binary system. Binary system. Write these numbers and remember carefully. No need to by heart. Any number given, just learn the method how to convert. Enough. For example, if we will take a 2 plus 3, if you add, so 2 plus 3 if you add, what will get? 2 plus 3 if you add means it will be easy. Correct? In a binary system, it will be equal to 5. Same way, here for example, I am writing a 1 0. Correct? 1 0 will be added to 1 1. Check what will get. So 10 plus 11 is not equal to 21. So it is only in a case of the decimal system that is a 10. But in a binary system it is called 1 0. It is called only 1 0. Correct? In case of the decimal system that is called 10. But in a binary system it is called 1 0. So it is a 1 0, but this will be equal to 1 1. If you add both, check what you will get. If you are adding both means 0 plus 1. 0 plus 1 is equal to 1. You should write this value is equal to 1 you should write. But 1 plus 1 is equal to what you should write. Correct? 1 plus 1 is equal not to 2. In the case of the decimal system, 1 plus 1 is equal nothing but what? 2. But here 1 plus 1 is equal to, you should write sum and carry you should write. Correct? Sum and carry. For example, if 6 is there, 9 is there, if you want to add, what we have to do? Or it is equal, for example, 19 is there. 9 plus 6. 9 plus 6, 15. So directly you should not write 15 here, correct? What you have to do in 15, so this digit I am writing here, remaining 1 will be carried to here, correct? Carry. Same way you have to follow here, correct? Here also you should follow the carrying. Sometimes while subtraction, it is not possible, then you have to take borrow. Here also same, sum and carry you should write. So this total value will be 5. Then check here, 5 will be equal to how much here? 5 will be equal to here 0 0 1 1 2 1 0 3 means 1 0 4 is equal to 1 1 but 5 is equal to what? 1 0 0. So here you should write this value. What you should write? So total value will be equal to 1 0 0 you should write. 1 0 1 this one. So this is 0 0 1 1 2 is equal to 1 0 3 1 1 4 1 0 0 sorry 5 1 0 1 sorry 1 0 1 you should write like this. Here that means 0 plus 1 is equal to 1. Next 1 plus 1 is equal, you should write what you should write 1 0. 1 plus 1 is equal 1 0 means 0 you should write here and carry you should write here. Right? That carried whatever you have written that you should write here. This one. It is a process, but this will be equal to 5. And you have to compare also. 2 means 1 0, 3 means 1 1, but 5 will be equal to 1 0 1. So it is a method to add. So directly if you know, we can add. Otherwise the numbers we have to check. For example, 9 minus 4, correct, equal to, or 9 minus 3 should write, equal to 6. Same way here, 9 means what? Check your last number. 1 0 0 1 you should write, correct. This will be equal to 9. But 3 means what? 1 1. So 3 represents 1 1 you should write. Then we have to subtract this one. So if you subtract means 1 minus 1 is equal, you should write 0. Na? 1 minus 1 here, you should write 6, this value. 1 minus 1 is equal to 0. Next here 0 is there. Then you have to follow borrowing. So 1 you should take here, correct. In case of the binary system, if you take 1 borrow, that will be equal to 10. In case of the decimal system, if you borrow 1, it will be equal to 2. For example, here if you take the value 1 here borrowing, then it becomes 2. 2 minus 1 is equal to, what you should write? This value 1. Correct? And still remaining a 1 should write here this value 1 1 0. The 6 will be equal to 1 1 0. That method you have to follow. But not necessary, but generally you have to remember carefully. Like it is a method. If you directly unable to solve this one, just check these numbers. So 9 3 numbers we know, and 6 also we know. Just directly we can write 6 also there. Correct? It is a method to add or subtract in binary system. Correct? That's all. If you want to note down that 1 or 2 examples only. So these numbers I think you have written, you have copied. Binary and decimal system numbers. So this type of operations only performed by or used in Boolean algebra. So that Boolean algebra will be used by digital electronics. That's why inside the circuits in a computer or maybe laptop or maybe in case of the music systems or in case of the mobile circuits, so first whatever information given, that will be converted into 0 and 1. Then logical operations will be performed, and then after completion of the total operations or process, again while giving the output by using a transducers or by using circuits, they will be converted into normal form or reader friendly form. So then we will get the output value in normal way. So logic gate means already have given any digital circuit which performs logical operations. Here logical operation means maybe plus or maybe minus, or we can write into, or maybe nothing but called conversion or complementation. So this type of operations are called logical operations. Any digital circuit which performs logical operation can be called as a logic gate or logical gate. So there is a logic gate. But generally while performing operations, we have to enter all the readings in the tabular column. For example, in lab I want to conduct an experiment. First trial number we should write. Whatever the values are there, we should write one column. Whatever the output is there, you should write other column. So the table can be called as a truth table. A table which contains all the possible inputs and corresponding outputs can be called as a truth table. For example, I'll give one simple circuit here. A simple circuit I'll give like this. 2 switches I'll give here. It is one switch, it is second switch. So the total circuit will be connected like this. It is a switch A. So this will be switch B. 2 switches are taken and both the switches are connected like this, correct? And here I'll connect one cell or battery. So this will be, one battery will be connected, and again this will be connected to an electric bulb. The same will be connected to the bulb like this. Here there will be an electric bulb. So this will be bulb, correct? So the bulb can be generally taken as what? Output. Whether bulb is glowing or not can be taken as output. But these 2 switches are nothing but called inputs. Whatever we are giving input, whatever we are taking, that will be called as output. Why? So these two are called inputs. For example, I'll write one table here. A simple tabular column I'll draw like this. Just what is a truth table means to understand easily. So first I'll take the switch A. It is a switch A. Next switch B I'll write here. Next whatever output is there, that will be here written Y. So that Y is called output. So Y is called output means the bulb is glowing or not. We have to study. That's only output, simple, correct? Now first it is a battery, plus minus it is a battery. So I have switch on the battery, and after switch on the battery, both the switches are opened. Whenever both the switches are opened, what is the condition of the bulb? Both the switches are opened means not on condition, correct? Here current will not pass. Here also current will not pass. Then what is the condition of the bulb? Off condition, no glowing, correct? So that means the switch off can be called as, it is nothing but switch off condition. First switch is off. Second switch also off. But what about the bulb? Also off condition only, bulb will not glow. Now second case what I am doing means here switch A is opened but B is closed. Check here. A opened means switch A is off condition only, but B is on condition, correct? What about the condition of the bulb? Bulb glowing or not glowing, how to check? So current will flow, current will come like this, correct? But here also up to here current will come, here there is a breakage, so current will not flow along this path. But here current will move along this direction, and then bulb is glowing or not. So in this way the current is flowing, that's why bulb is on condition. So we can write bulb is on. Next case what I am doing means B is opened whereas A is closed. Check here. So that is A is on condition but B is off condition. Again, what is the condition of the bulb? On, because current will flow along this path, but no current flow along this path. So also bulb is said to be in on condition. Next case, both the switches are closed. Now check here. Switch A is on and B is also on, then bulb is also on condition only. So this type of table called a truth table. So what is a truth table means? A table which contains all the possible inputs. So these are called inputs and the corresponding outputs. This is corresponding output. So this type of table is called a truth table. You can write a table which contains all the possible inputs. A table which contains all the possible inputs and the corresponding outputs. A table which contains all the possible inputs and the corresponding outputs is known as a truth table. So in tomorrow class we will discuss what are the different types of the logic gates. AND gate, OR gate, NOT gate, NAND, NOR, different logic gates are there. We will discuss the logic gates and also for each and every logic gate symbol, truth table, one example we will discuss in tomorrow class. Okay, thank you.